Good morning, Year 11. So today we start looking at finding probabilities. So last lesson was looking at it in terms of the worded probability. Now we're involving our maths. Now we know that probability is always a fraction because it's between the numbers 0 and 1, okay? Which is basically what this big red box here says. So to find the probability of any event, to write it as a fraction in other words, we just put the number of outcomes they ask for over the total number of outcomes, okay? The other formula is that in probability, when you see the word and, so it might say find the probability of something and something, you multiply those fractions. But if it says find the probability of something or something, you add the fractions. So that's just the other general rule in probability. Okay, the next thing I want you to be familiar with if you aren't already is how a deck of cards works, okay? Now, basically, if you don't know, there's 52 cards in a deck, just as there's 52 weeks in a year. It's a nice way to remember it. Half of them are red, half of them are black. Then the red cards, okay, there's two suits that are red, hearts and diamonds. So now just thinking mathematically, if half are red, half are black, that means there's 26 that are red, 26 that are black. Then half of the red ones are hearts, which means there's 13 hearts and 13 diamonds. 13 clubs and 13 spades. So then in each suit, you have king, queen, jack, 10, 9, 8, 7, 6, 5, 4, 3, 2, all the way down to 2 and then ace. So there's 13 of each one of those, which now, looking at it, you could say, well, how many cards in a deck of cards are black? There's 26 out of 52, which is 1 in 2. How many cards are diamonds? There's 13 out of 52, which simplifies to 1 in 4. How many kings are there? There's 4 kings in a deck of cards. How many number 3s are there? There's 4 number 3s in a deck of cards. Okay. Otherwise, I'm sure a lot of you already know most of that. Let's have a look at some probabilities then. And I bet you could pause this video and do most of these on your own. So go ahead if you want to. Otherwise, we're writing these. Now, the biggest thing you need to make sure you do in probability is simplify your answers. You will not get it correct if you don't simplify. All right, so find the probability of the following. A head being tossed on a coin. Now, what I want you to get in the habit of doing is write like this. So the probability of heads is equal to 1 in 2. Nice and easy, but it's that notation that I want you to be familiar with. So you can simplify or abbreviate the value in the brackets. So the next term, the probability of a red card in a deck of cards. Well, we know that there's 26 red cards out of the 52, which is also the same thing as 1 in 2. So again, pause the video. You can jump straight to the simplified answer if you know it. Probability of getting the number 4. Well, there's 4 of them in 52, which simplifies to 1 in 13. Now, if you're not great at simplifying fractions on your own, all you have to do is put 4 over 52 in your calculator and press equals, and it will simplify to 1 over 13 for you. The probability a number smaller than 6. Well, let's think about that. Some thinking. I've got probability, that means cards could be a 5, a 4, a 3, a 2, or an ace. So that's 1, 2, 3, 4, 5 different numbers it could be. And I know there's 4 of each one of those numbers in a deck of cards. Okay, so 1, 2, 3, 4, 5, multiply that by 4. There's 20 possible cards that are smaller than 6 out of 52. Probability of less than 6 it is. And again, simplify that. Straight away you could halve both. That's 10 out of 26. Halve it again, 5 out of 13. Or put in your calculator. An even number. Interesting. An even number. So what you might want to do is come back up here to the visual, okay, and think, okay, what have I got that are even numbers? Well, jack, queen, king, they are nothing. So I'd have 10, 9, 8, 7, 6, 5, 4, 3, 2. So I'm visualizing it. Okay, so 8, 6, 4, and 2. So there's 1, 2, 3, 4, 5 cards there. I know there's 4 of each one of those, which means there's 20 cards altogether that are even. So the probability of even, there's 20 of them out of 52, which is the same fraction as above, and I know that simplifies to 5 on 13. The next one, the number 4 or 5. Straight away, I'm thinking, hang on, what did Miss just say about or? Or means you plus the fractions. So, all I have to do is say, well, how many number 4s are there? Getting a 4 is 4 on 52. Or getting a 5 is, there's also 4 of them out of 52. Which gives me a total of 8 out of 52. Which gives me 4 out of 26, which is 2 in 13. Now again, if you could jump straight to the 8 out of 52, that's fine, you can. Okay, interesting, not a 3. Well, how many 3s are there in a deck of cards? There's 4 lots of the card with a 3 on it. Which means the remaining would be 49 of those, 48 cards out of the 52 are left that are not the number 3. Simplify. There we go. Okay, now I went through those quite quickly just because I do expect that you know most of those already, if not all of them. Okay, it's pretty basic junior school probability. But now let's have a look at these harder examples. If I draw a 4, what is the probability the second card is a 4? So let's think about this. I haven't mentioned, I'm going to actually put in here without replacing. So let's think about my deck of cards. I've picked out a 4 and I haven't put it back. What's the probability of then pulling out another 4, the second card being a 4? So, probability of second equaling a 4. Well, I'm going to only have 53 cards left. Oh, sorry, 50, can't count today, 51 cards left in the deck because I've already pulled one out. And there's not going to be 4 cards that are 4s now. There's only 3 of them that are left. Okay. The next one, the numbers 3, now this has nothing to do with the card question, okay, this is separate. The numbers 3, 8 and 2 are formed as a 3-digit number. Find the probability that it's even. So let's think about that. Let's just say on a piece of paper there's a number 3, a number 8 and a number 2. Now these could be arranged in all different ways. I could have 8, 3, 2, for instance, etc. They want to know, find the probability the number is even. The best way to do these is, there's not too many here, okay? There's not too many numbers here, so I could write out all the possibilities. So let's think about this. I could say, okay, I could have 3, 8, 2, 3, 2, 8. I could have 8, 3, 2, 8, 2, 3, or I could have 2, 3, 8, and 2, 8, 3. So there's all the possible ways I could arrange those 3 cards. There wasn't many numbers, so it was pretty easy to just work that out. So now I look at them, I go, okay, well there's 6 different options. So how many of these options are even? Well, they must just end in an even digit. So I've got this one is even, 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 even. So the probability of getting an even is equal to 4 of them out of the 6, which is 2 out of 3. Okay, the next one says probability that it starts with the number 2. Well, there's 2 of them out of the 6. So 1 in 3. And the probability that it's greater than 320. Well, I've got not either of the 200s. So that one is, that one is, that one is, and that one is. Which gives me 4 of them out of the 6, which is 2 out of 3. So it is often a great idea to do the visuals next to you, because that question would have been a lot harder if I didn't have that visual aid next to it for me. Okay, and that is the lesson for today. Again, nice and straightforward really. You're just practicing those probability skills that you already have done and seen before. So I want you to have a go at 5B today, doing those questions. And if they do have letters, I want you to do all the letters in that question for me. Don't forget to take a photo and upload it onto Teams for me. If you are having trouble uploading a photo, just email me and let me know you're having some troubles, and I can try and fix it for you.